Space nuclear power and propulsion can enable exciting missions throughout the solar system. Nuclear thermal propulsion systems underwent extensive development in the 1960s and early 1970s. Space nuclear power systems have flown in space and could potentially enable a power-rich environment anywhere in the solar system at any time. Space nuclear systems can also operate in hostile environments, including dust storms and high radiation fields. Nuclear power systems have to date been used to provide up to 900 watts of electricity for deep space missions. In addition, significant design and testing efforts have been performed in support of systems capable of providing 1 million watts of electricity or more. NASA's current fission technology effort is focused on a 40,000 watt system that could be developed into a workhorse power supply for NASA and provide a foundation for development of highly advanced space fission systems. A team consisting of 2 NASA centers and 4 DOE national laboratories has made significant progress related to the 40,000 watt system, and significant testing has been performed. The purpose of this Innovation Fund project was to perform research related to ultra-compact fission systems capable of providing up to 3,000 watts of electricity for a variety of space missions. One potential use for the system would be advanced science missions with power requirements too high to be met by radioisotope systems, but much lower than those of typically proposed space fission missions. To be useful, the 500 to 3,000 watt electric system must be safe, reliable, compact, and have greater than 10-year life potential. A NASA DOE team completed a pre-conceptual design of such a system in April of 2010. Although the team is confident in the design that was developed, some technical questions remain. One of the technical questions is the need to verify the fundamental stability of space reactors cooled by heat pipes. A significant portion of this Innovation Fund project was dedicated to investigating that potential issue. Omar Morales, a co-investigator on this project, has been investigating issues related to the stability of heat pipe cooled systems.
One of the concerns for using heat pipe in a space nuclear system is its thermal stability. And what we have here is a heat pipe inside a vacuum chamber with a heat exchanger attached to the condenser into the heat pipe. And we flow a high amount of nitrogen gas through there to do rapid cooling of the condenser. And to show you a better idea of what we have in there, it's a stainless steel heat pipe with sodium as a working fluid. And although the majority of the work that we do is non-nuclear in nature, the way in which we achieve the thermal response is by using resistance heaters. And here we have an electric graphite resistance heater. This heater provides a comparable temperature profile we'd expect to see in a nuclear fuel element. And we have 3 of these surrounding the heat pipe. And a heat pipe is just a real simple design in that as the heat is applied to the evaporator end of the heat pipe in this section, the sodium working fluid on the inside becomes a vapor, which then travels its way down to the condenser end right here where it condenses, releases the energy, and then when it becomes a liquid, it moves its way back into the evaporator. So essentially what you have is a solid state heat pump with no moving parts, so it has high reliability. But one of the questions that we had was, if you do a rapid cooling of the condenser section, will that cause thermal instability that will then propagate its way back into the core? And what we found with the data so far is that even under extreme temperature transients on the condenser end, that instability will not propagate back into the reactor core, so that they should be suitable for application in the space nuclear power system.
Space nuclear power has the potential to enable a power-rich environment anywhere in space at any time. This Innovation Fund project has been successful at investigating potential issues with one fission system of interest.